Hey sophomores, welcome back to Written Theory 4. Today we're going to talk about serialism, which is making a piece of music based on having a set of notes in a specific order. And by now you've watched and discussed, I assume, the John Tavener composition, The Lamb, that I assigned you. And it's a great example of serialism. You've watched the analysis video that shows how the melody gets transformed. Let's go ahead and convert it into pitch class numbers to kind of visualize easily some of the math involved here. So here's our original melody. Pitch class 7, I've taken out all the repeated notes. Pitch class 11, pitch class 9, pitch class 6, back to pitch class 7 at the end. Little lamb, hope made thee. There's our melody. You can see it goes up 4 half steps, down 2 half steps, down 3 half steps, up 1 half step. So the beauty about pitch class numbers is it makes it really easy to do intervals based on the number of half steps there. Of course, the alto line comes in and mirrors it. And a lot of you pointed that out. And yeah, you can see instead of going up 4, it went down to 4. Instead of going down 2, it went up 2. Down 3, up 3. And down 1 at the end instead of up 1 at the end. And so if we talk about our original version, or the prime version of the row being what we're going to call the set of the notes all in order, lined up in a row. There we go. So the notes in order, that's our row. And this is the prime version of the row. Just like after Crisis on Infinite Earths, all that was left was Earth Prime. Or we talk about the prime material plane in Dungeons and Dragons, but the prime is the original version. And this is the inverted version of the row here, as we look down there, is, 7, 3, 5, 8. That's an inversion. And Tavener then goes on to take 7, 11, 9, 6, and he adds the inversion to the end of it, 3, 5, 8, to extend the row out even further in the melody. Da, da, dee, da, 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 dum. And then he promptly does that backwards. Dum, da, 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 dum. And so now I have not only the prime version of the row, the prime form, that goes 7, 11, 9, 6, 3, 5, 8, but we also have the backwards version that goes 8, 5, 3, 6, 9, 11, 7. And the backwards version is what we call the retrograde version of the row. Tavener, of course, then goes on to harmonize both the prime and retrograde with the inversion, and therefore the retrograde of the inversion. The inversion also, you can see, goes forward 7, 3, 5, 8, 11, 9, 6. See if I can point it up here. It's right in the camera. But then it goes backwards 6, 9, 11, 8, 5, 3, 7. And so the retrograde of the inversion we just call the retrograde of the inversion. And we can label all of these as such. The prime form starting on pitch class 7. The retrograde of the prime form that starts on pitch class 7. Notice that retrogrades we name by the last note, so that it is the same number as the prime form that it relates to. Then I have the inversion starting on pitch class 7, and the retrograde of the inversion that started on pitch class 7, the retrograde inversion of 7, of course, ending on 7 at the end there. And this prime, retrograde inversion, and retrograde inversion are the basic forms of a row. Of course, they could start on any of the 12 pitch classes. I could have a P0 that started on 0. There goes 0 plus 4, 0, 4, 2. 2 minus 3 takes us to 11. 8, 10, 1, and then backwards from that. So that would be the P0 of the form. And of course, the guy who came up with this system of serialism, Arnold Schoenberg, you guys know him, you guys love him, fantastic composer, brilliant theorist. He got a little bit frustrated as he was writing his atonal music that we've been analyzing. he sensed that there were rules there, but he didn't exactly know what they were. That was a great quote to put in my master's thesis when I figured out some of the rules. But in order to know what the rules were, he kind of created his own system of composing music to completely replace tonality. And so he didn't have to compose on instinct. He could compose via intellect. He could make the rules and follow the rules for his particular piece. And he used all 12 tones. He was trying to equalize the tones, very, very democratic of him, and make them all special. We've talked about how he thought of pantonality, what we now call atonality. But if we use all 12 notes more or less equally, then they're pretty equal notes. And so he put all 12 in a row and didn't come back to them. It's a simplification, but doesn't come back to them in the row until he's moved through all 12 of them. Let's go ahead and take a look at a piece of music here that Schoenberg wrote, his Opus 25. We'll look at the prelude to it. So from a suite of music he wrote, his Opus 25. Move the mouse over here, so there we go. First of all, let's take a listen to it. It's going to sound a little bit different, I think. Yeah, that's the introduction to the prelude anyway. Definitely no sense of tonality there. We have no idea what note is do. And so I think he succeeded in his goal. There are musical elements that make sense. I mean, if you look here, you can see is kind of mirrored. And so there's a little bit of a canon going on between the melody and the responding melody here. So a lot of the standard methods of writing things, Schoenberg loves sentence structures, Schoenberg loves forms, and he likes counterpoint. Yeah, so he does all these things. He's just not using do anymore, no more tonality. And if we take a look at that melody of his, and you go through and you realize, aside from the fact that he's repeating the B flat, but rearticulations of a note don't count as new versions of that note. He's used all 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all 12 chromatic notes of the scale in this melody. And so I could just, kind of lay those notes out here using the pitch class numbers of these notes: 4, 5, 7, 1, 6, 3, 8, 2, 11, 0, 9, 10, 10, 10. And this is the prime version of the row that he's using in this piece. And the piece is going to be built off of things that are related to this series of notes. It's serialism. The notes are in order. They are a row. And so we would call this P4. And you can see there, if you can read that small thing, P4, I've labeled this, and all those red notes are P4. Now, P4 isn't the only thing that Schoenberg uses here. Just as Taverner liked to use the inversion of the row that he came up with, we could construct an inversion of Schoenberg's row here as well. We're going to go ahead and move the score out of the way here for a moment and just look at this. But you can see 4 to 5 is up 1, 4 to 3 is down 1, 5 to 7 is up 2, 3 to 1 is down 2, 7 to 1, that's a tritone, 1 to 7 is a tritone, 1 plus 5 is 6, 7 minus 5 is 2. And if you go through, you will find that the inversion of our original form, so this is P4 going from left to right, and the inversion goes from top to bottom, and we would call this I4, the inversion starting on pitch class 4. And you can see it also uses all 12 notes in a certain order. So Schoenberg has access to the P form starting on 4, the I form starting on 4, or any of the 12 P forms. If we build a P form on 3 going across using these numbers on top, and a 1, and a 7, and 2, and a 5, 0, and do P forms on all of those, we get what's called the matrix. And the matrix, you can read from left to right, it has all 12 versions of the P form. So P4, P3, P1, P7, P2, P5, P0, P6, P9, P8, P11, and P10. Reading from top to the bottom, gives us the 12 possible I forms of the row. I4, I5, I7, I1, I6, I3, I8, I2, I11, I0, I9, I10. Going from right to left gives us the retrograde. So R4, remembering that we named the retrograde by the last note of the retrograde, which is the first note of its related prime. R4, R3, R1, R7, etc., etc. And of course, bottom to top gives us the retrograde of the inversion, the Ri forms, Ri4, Ri5, Ri7, etc. Let's take a look at the score. I've gone ahead here and I've put the matrix up down in the corner there so that we can reference it. And I see that in the purple here, maybe zoom in a little bit, we can maybe see it a little bit more clearly. Yeah, that's good. I see the notes B flat, C flat, D flat, G. Just to say, pitch class is 10, 11, 1, 7. So I'm going to go looking on the row for 10, 1, or 10, 11, 1, 7. And I see it on the bottom row there. 10, 11, 1, 0, it's P10. So I'm counting the numbers 1, 2, number 3, number 4, number 5, number 6, number 7, number 8. But then notice pitch class is 5, 6, 3, 4. He's actually gone back. Pitch is number 10, 9, 10, 11, and 12 here. He's actually gone back and he's using 9, 10, 11, 12. At the same time, he's using 5, 6, 7, and 8. Schoenberg will often use sets of 6 notes, the hexachord. If you can divide the matrix in half, you'd have 2 hexachords. He likes to use hexachords against each other, and he likes to use tetrachords against each other, just groups of 4 notes, and so those are fairly common. You can see then we've got different row forms coming in. There's an inversion of pitch, inversion starting on 10. That's the right row of the column, 10, 9, 7, 1, 8, 11, 6, 0, 3, 2, 5, 4. And you can see in the melody, there's the repeated B flats become overlap with the last pitch of P4 is the first pitch of I10. And you can count through the row form here, 9, up to 7, 7, skipping to 1. Now at this point, if you go back, you notice that the pickup to the end of this measure here, there's the pitch class 8. That's the 5th note of I10. And he goes 5, 6. There's our 11, 6, 0. Notes 7 and 8. And then underneath that, there's pitch classes 3, 2, 5, and 4. And so he's actually got kind of 4 plus 4 plus 4. He's harmonizing the row with itself kind of tetrachordally. And here he takes advantage of the fact that pitches 3 and 4, pitch classes 7 and 1, the 3rd and 4th pitches in I10, are in fact the 4th and 3rd pitches of retrograde 10. Remember, he had prime form 10 earlier. Now he's using the retrograde 10. And so on the bottom row, reading from right to left, you can see the pitch classes. Well, let's just go from the end. We're counting backwards in the music. We're counting forwards across the bottom row. So 10, 11, 1, 7. And he's taking advantage of the fact that that 1, 7 shows up in the same order, 7, 1, in the inversion I10. So he's using that to overlap. Also, it's showing up in the same area that it showed up very prominently at the beginning. So he's using that as a motive. And when we have groups of notes that stay in the same order across multiple forms of the row, we refer to those as invariants. They don't change their order in different parts of the row, and Schoenberg likes to use those as motifs, if you will. And again, he's harmonizing those 4 notes, 4, 3, 2, 1. Technically, I should count those. No, I'm doing it right. 4, 3, 2, 1. Yeah. And 8, 7, 6, 5. and the last 4 notes as well. Pitch classes 4, 3, 6, and 5. You can see those are notes 12, 11, 10, 9. If you're going backwards in the columns, column 10, 12, column 11, column 10, column 9. And so when we analyze a 12-tone piece, we count out the rows. We call this row counting, just to trace which rows he's using. Prime form 4, prime form 10. He likes, obviously, deliberately juxtaposing that tritone here to increase some dissonance. And since he's using the prime form 10, he's using the inversion 10 as well. And then the retrograde 10. I don't know why I called that R10 there and IT here, but either way, whether you're saying 10 or T, it's 10. I like to use T and E for 10 and 11 because you don't get confused with 1 and 0 followed by 1 and 1. But that's an introduction to serialism, and I've given you an assignment to go row count his 4th string quartet at the beginning of that. Very, very memorable melody. That's the 12-tone melody that I have stuck in my head at any given time. It's a favorite of mine. So go ahead and row count that, and we'll come back and do more with serialism next week.